in a fictional meeting of three very interesting but different characters was going on, and the discussion was all about resting and recovery period. The characters were the great 100-meter sprinter Usain Bolt. The second character was an alligator, and the third one was a migratory bird. A common question was asked to all of them, and the question was, after doing your function or after doing your activity, how much time it take for you to take a rest or recovery? The answer from Usain Bolt was 30 minutes, and the answer from the alligator was 3 to 4 hours, sometimes 6, 7 hours, and the answer from the migratory bird was very interesting, no rest at all. Now, if we look closely, why these three characters are having different timings of rest and recovery, then we will be getting astonishing idea about the metabolic pathway called as glycolysis. Now, in a situation where muscles require a quick burst of energy, then they face hypoxia, or a condition where the oxygen supply is less. Imagine Usain Bolt is going for a 100-meter sprint. What is happening? He's trying to utilize a burst of energy for next 8 to 9 seconds to run very, very fast, and during those 8 to 9 seconds, his leg muscles or skeletal muscles are not getting oxygen supply from lungs because they are far away from the skeletal muscles. Now, in that condition, muscle cells do what? In the absence of oxygen, to produce higher energy, they do rapid and multiple cycles of glycolysis. And since this glycolysis is happening in anaerobic situation where oxygen is not available, the muscle cells start producing lactic acid. So, in those 9 seconds, there is accumulation of lactic acid, which is reutilized after the race by using the pathway of gluconeogenesis, and after some time or after some rest or recovery, the lactic acid will be vanished because it will be completely reutilized. So, it totally depends how fast you are using a burst of energy, how much lactic acid you are producing in your muscles, and if the amount of lactic acid is very high, then the rest and recovery period will be longer. Now, if we look at the alligator, alligators are generally calm organisms, but when they are threatened, they quickly move, they run very fast, they use their tail, and tail is very far from the lungs, so they use a short burst of very high energy by doing multiple cycles of rapid glycolysis, and they accumulate hell lot of lactic acid in the muscles. Higher accumulation of lactic acid means longer recovery period or longer resting period. That is why alligators are taking 4 to 5 hours, sometimes 8 hours of recovery and rest. When we look at the migratory birds, they are flying for 15,000 kilometers, 20,000 kilometers over the ocean without taking any rest. How they are able to do that? Because their flying muscles are near to lungs. So, they never face a situation where the quick burst of energy is required and oxygen supply is not there. They are having appropriate supply of oxygen. And since the oxygen is there, there is no need to make lactic acid, there is no need to do anaerobic respiration or anaerobic glycolysis. And if you don't accumulate lactic acid, you don't need recovery and you don't need the resting period. From the experience of these three characters, what we are learning? If your skeletal muscles, which are using the burst of energy, are far from lungs, then those muscles, while they are doing exercise or where they are doing some acute higher function, in that case the oxygen supply will not be adequate, anaerobic glycolysis will happen, lactic acid will form, and this lactic acid will be reutilized in gluconeogenesis, but that will take time, and that time is equal to rest and recovery period. And if your acting muscles are near to lungs, then the situation will not arise and the requirement of rest and recovery will not be there. Imagine if Mother Nature has kept our heart near to our knees, what will happen? Whenever heartbeat will be faster, since heart is made up of muscles and they are very far from the lungs, in that case, it will start doing anaerobic glycolysis, it will start accumulating lactic acid, and you actually don't want your heart to take a rest and recovery. You want your heart to work continuously, every minute, every second. So what is the best way to do it? Just keep it between your oxygen chambers so they never face the inadequate supply of oxygen. 3 characters and very interesting idea and explanation about anaerobic glycolysis, recovery and rest.